Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today's topic is on-chip memory internal RAM. So in 8051, what is an on-chip memory available and how the RAM will be mapped. So that's we are going to discuss today's class. Look at this. So in on-chip memory, so from 00 to 1F, so this will be allotted for the general purpose registers. Actually, we use only 8 registers, that is R0 to R7, but we use 4 different banks. But at a time we can use only one bank, so that will be selected in the register select bits. So that will be available in this area, that is 00 to 1F. That is a 4 bank and each bank have this 8. So 4 into 8. And then look at this. Next will be bit addressable memory locations from 20 to 2F. So we have this location. So this will be used for a bit addressable data. So these data can be accessed both bit addressable and byte addressable. So whenever you use a byte address, we can access the entire 8-bit data. Whenever you use and access this bit address, so we need to access that particular individual bit only. And then from address 30 to 7F, so this is the address for a direct and indirect addressing. So whatever the data we are going to access directly or by using indirect addressing mode, so that will be available in this range from 30 to 7F. From 80 to FF, so this is an upper 128 byte RAM. There is a lower 128 BAM, so that will be used for this general purpose bit addressable and direct indirect address. And the remaining 128 byte upper RAM, so this will be used only with this indirect addressing only. So here only that SFR register, that is a special function registers also mapped with corresponding addresses. So this is the lower 128 bit RAM and this is the higher 128 bit RAMs. So this will be used for this general purpose registers, bit addressable and direct indirect addressing, and then higher 128 bit that will be mapped for this SFRs. Look at this detailing. The first one, general purpose registers, I already told you, from 00 to 1F. Look at this, 00, 01, 02, up to it increases up to this 1F. So look at this, we have the register R0, R1, R2 up to R7, totally 8 registers. R0 to R7, we have a totally 8 registers. This is bank 0. So again from 08 to 0F, the same register R0 to R7 will be available, that is comes under the bank 1. From this 10 to 17, similarly we have the same R0 to R7 with the bank 2, that is a 10 to 17. In bank 3, from 18 to 1F, we have the same register R0 to R7. So we have a 4 bank, but at a time any one bank will be selected by using this program status where register bit number 2 and 3. So these 2 bits maybe we use 00, 01, 10 or 114 combination. So when we have 00, bank 0 will be selected. When we have this 01, bank 1 will be selected. We have whenever 10, bank 2 will be selected. 11, bank 3 will be selected. So any one bank will be selected at a time. So whenever we use subroutines or interrupts or some other function jumping, so instead of storing all the registers, simply we can shift from a bank 1 to bank 2 or bank 2 to bank 3. So if you shift from one bank to another bank, so whenever we use that R0, R1, that corresponding address only accessed. Look at this next one, bit addressable memories. So general purpose, after that we have this bit addressable. So if you look at this 20 to 2F, look at this. We have this 20 to 2F, so this will be mapped. So 20 we have this 00 to 07. Again 21 we have this 08 to 0F. Next 10 to 1F. Again we have this 18 to 1F. Then 20 to 27. Again 28 to 2F. So each location that will be accessed by using both bit address and byte address. So when we use this byte address to access that particular data, the entire 8 bits will be copied by the data bus. Whenever we use this bit address to access that particular location, the individual bits will be accessed. So the data will be remain same. So whenever we access that, we through this bit address or byte address, we get the same data. So whenever we have sensors or bit informations, there the bit addressable is the best thing to the store. Look at an example for bit addressing. Look at this. Move C, 1A. That means the content present in this 1A location will be moved to carry bit. Look at this. This is the 1A bit address. So from this bit address, the content may be 1 or 0. The data will be moved to carry bit. So for a bit addressing, so the accumulator or a content will be used as a carry flag. So next will be SFR, that is a special function register. Look at this, the above this will be a special function registers. So from an address 80 to FF, that will be used this. So we can access that particular registers like a TCON, TMOD, SCON, SMOD or a PCON. So many SFR registers will be available that will be accessed by using this SFRs. Look at this data register, control register. For a timers we use TCON, TMOD like that. Serial ports we use like an SCON, SMOD other things. Interrupt we can use an enable bits and interrupt priority bits. So IP and IE bits. So analog to digital converters, digital to analog converter extras. So these things we use this SFR registers. Look at this mapping of this. So this is the default bank 0, bank 1, bank 2, bank 3, and then we have the bit addressable location. Look at that. So byte address 20, bit address is 00 to 07. Similarly 08 to 0F, that byte address is 21. So individual bits will be accessed by this bit address. Above that we have this, look at this 27 from 28 to mapping. So 20 to 2F, entire things will be bit addressable locations. Above the 30 to 7F, this is the general purpose RAM. Above that, the SFRs, look at this 80, this will be used for this P0 port 0, SP stack pointers. These are not bit addressable. So whenever it is a bit addressable, we have both byte address and bit address. The left side to this, so this is the, so look at this, if you take a port 0, the 80 is a byte address, and then 80 to 87, this is the bit address for individual bits. For example, if I want port 0 lower bit, that is pin port 0 dot 0th pin means I can use this 80. First pin means I can use this 81, 82, 83. If I want port 0 7th pin, P0.7, I can use this address 87. Similarly, if you take this TCON, this is also bit addressable from 88 to 8F. See, normally how they mapping means the same that address. Look at this. This is an 80 now. Same this 80 is used for this LSB bit. Look at this 88. So that will be for an LSB bit. Look at this 90. The same bit address for the LSB bits. So that's why only the random locations will be mapped for that particular addresses. So that will be the predefined. Look at this 80 will be mapped for port 0. But if you take a port 1, it's mapped to 90, not 81, 82, 83 like that. Because bit addressable location 8 where we have taken this, so automatically next will be 88 only, so that will be allotted for TCON. Look at this, this is port 1, this is port 2, that is a A0, and port 3, that is B0. Similarly, look at this, port 2, this is a bit addressable, port 3 is bit addressable, interrupt enabled register IE is a bit addressable, program status bit is a bit addressable, accumulator and B register bit addressable. If you take this SBUF serial buffer, stack pointer, data pointers, PCON, timer lower, higher of timer 0 and timer 1, these are the not bit addressable locations.